Mrs. Abrams and I had a jolly good time playing skee-ball, and we collected some data while we were there. So that random variable x represents my scores and random variable y represents Mrs. Abrams' scores. Okay, let's just pretend, because actually we're social distancing, so we did not go play skee-ball. This is all pretend. But imagine that we did in our minds. So the first thing is, are x and y discrete or continuous? Well, can x take on values that could be potentially decimals? Or is there some value in between each of the values that it could take on? So let's look. X could take on 10, 20, 30, 40, or 50. Those are the only values that my random variable can take. So this would be discrete, right? Because it's almost like it's jumping from 10 to 20 to 30. It can't take on values in between there. So they are discrete. So what about, let's verify the probability and verify that each distribution is valid. So remember how we do this? We add up all of the probabilities, and then we make sure that they add up to 100. And then we also make sure that none of these numbers, none of these probabilities is above 1. So I can see right now that all of them are well within the range. So I'll let you go ahead and add them all up and make sure that they are valid. So let's find the probability that x is greater than 40. And so that means find the probability that I get a score greater than 40 when I throw one ball, right? Because x represents one ball. Okay, and so if I do it with one ball, what is the probability that that would be a score greater than 40? Well, for x greater than 40, that would be 0.14 plus 0.06, because it's the probability of getting a 40 or a 50, which is 0.2. So I have a 20% chance that I will get 40 points. What about Miss Abrams? Probability that y is greater than 40. So we have 0.1 plus 0.05, so that equals 0.15. So she has a 15% chance that she will get 40 points on one ball. So my question for you is, based on this, who do you think is going to win? And to me, it looks like that I would win, right? Because I have a greater chance of getting a higher value on this ball. But what you might be thinking is, what about all of the different ones? I mean, am I really getting, if I add up all of mine, because if you look at mine, I get lots of 10s and she does not get very many 10s. So this is not a very good way of figuring out who's going to win, because it doesn't take into account any other numbers. It just says, oh, the probability of getting a higher number is good for Mrs. Barney, therefore she must be better. So what we're going to do is we're actually going to put this information into an applet, and we're going to figure out what the standard deviation is and everything, and that'll help us see. So you're going to go to statsmedic.com, and then you're going to click on Resources and Applets. And then you're going to come down here to Discrete Random Variables, and you're going to put in these different values. So we're going to put in the different value of 10 has a probability of 0.4. The value of 20 has a probability, and these are all the probability of x. So this is the random variable x that we're talking about, which are my scores. A score of 30 has a 0.2, a score of 40 has a 0.14, and a score of 50 has, ooh, I messed up there. Let's see, 40 has 0.14, and 50, I had a 0.06 chance. Okay, so then we click Begin Analysis, and we look, this is the histogram that shows this, because remember, these are discrete variables, so it's just showing us 10, 20, 30, 40, 50. And so it shows our different probabilities for each. Now we can look at the skew, and we can notice that I get a lot of low numbered balls. So the summary tells us what is my mean, my average score. My mean score is 22.6, and my standard deviation is 12.777, which means that on average, the values that I throw are within 12.77 of 22.6. So on either side of that. So then what I want you to do is do the same thing for Mrs. Abrams, and I want you to fill in at the bottom and see who do you think is going to win based on our mean scores, because like we said, the other way was not really a good indication of who was going to win.